What's up guys, in this Unreal Engine 4 tutorial we're going to be setting up a classic camera-based system similar to Resident Evil or Dino Crisis. We'll be covering tank movement with the option for turn-in-place animations, a custom volume that will switch the camera depending on which side the player exits from. We'll be exposing properties for the volume such as which cameras are connected to it, and also for adjusting the width and height. And we're going to be tackling pretty much all of this through C++. Okay, so the first thing we're going to do in this tutorial is make sure that we've got some input mapping set up. We're going to come up to Edit, Project Settings, and then we'll come to the Input tab, and we're going to add in an action mapping for sprinting, which will just be under left shift, and the axis mappings will have move forward with WS and the scale values, -1 on the S there, and for turning, we're going to have A and D for that, and the scale value is going to be -1 on the A. So you can pause the video here and copy those settings, and then once you've done that, we can move on. Now let's set up our C++ character class. So we'll come to the C++ classes folder, and we'll come inside here and we'll right click and create a new C++ class. We're going to look for the character class and we'll hit next. We're going to make it public and we're going to put it in a folder named pawns. And we're going to just name this player character and we'll hit create class. Okay, so now inside the CPP source file of the player character, we're going to add some lines of code just to the constructor here. So our character is going to be able to rotate on the spot, and in order for us to be able to do that, we want the character class to ignore the yaw controller rotation. So to do this, we can just type in B, use controller rotation yaw, and set it to false. And while we're here, we can adjust the relative location and rotation of the character mesh so its feet hit the bottom of the capsule, and that is rotated the right way for us. To do this, we're going to use the get mesh function, and we're going to use the set relative location on this, which will be an F vector, and that is going to be 0.0, 0.0, and then -90. Let's do the same for the set relative rotation. We'll use an F rotator for this. And then this is going to be 0.0, -90, and then 0.0. Okay, that's all we're going to do in the constructor for the time being. Let's go on and switch over to the header file. Now inside the header file, let's go ahead and declare our movement functions. Our first movement function we're going to declare is move forward, and this is going to take a float parameter named input axis. Our second movement function is going to be turn, and this is also going to take a float parameter named input axis. Now we're going to declare some sprint functions. First one is going to be start sprint, and the second one is going to be stop sprint. And while we're here in the header file, let's go ahead and declare some properties. We'll start off with a U property, which is going to be edit anywhere, blueprint read write, and the category we can just throw into character movement. And we're going to declare this as a float, and it's going to be named turn amount. We'll be taking this and using it in an animation blueprint so we can drive some turn in place animations. Let's copy the U property line so we don't have to type it out again. We'll paste it down here and we're going to declare another new float, and this is going to be our walk speed. We're going to give this a default value of 125. Let's paste the line in again. Let's declare another new float. This will be our run speed or our sprint speed, which will have a default value of 500. Now let's come back to where we declared the movement functions, and let's create the implementation for each one of these functions. Okay, now we want to make sure that we bind our input events to these movement functions. To do that, we want to make sure we include the header file for the input component, which is under components/input component.h. Now let's come back to the setup player input component, and let's bind our axis events just here. So our first input component axis event is going to be the move forward. We want to bind this to the reference of our move forward function within the player character. Okay, and the next one is going to be bind axis for turn, and we'll repeat the same steps as above. We'll tie this to the reference of our turn function. Now let's move on to the action events. The first action event we're going to bind is for the start sprint. We want to make sure that we use the name of the action event, which is just going to be sprint. And this is going to be for the pressed, which will be linked to the reference of our start sprint function. And finally, we'll move on to the stop sprint, which will be bound under the same action event named sprint, but this will be input released, and then this will be linked to the reference of our stop sprint function. Okay, let's move on to setting up the move forward function. So to move the character forward, all we have to call is the add movement input function. And this takes two parameters. The first parameter is the world direction. We can use the get actor forward vector function for this. And the second parameter is the float scale value. We can just use the input axis. Now for the turn, we are going to set our turn amount to the value of the input axis here. To make our character rotate, we can simply call the add actor local rotation function. This takes in an F rotator, and the pitch is going to be 0. The yaw is going to be our turn amount, and the roll is going to be 0 as well. Now moving on to the sprinting functions. We're going to be editing properties on the movement component, so we just want to make sure we include the header file for that, which is going to be under game framework / character movement component.h. Now back to our start sprint function. To start our sprint, we can call the get character movements function, and then inside this we will just set the max walk speed to the run speed. And for the stop sprint, we are going to call the get character movement function once more, and we will get the max walk speed property and set it to our walk speed, because we'll be stopping our sprint, returning to the walk. And one final thing we want to do is come up to the constructor and just set the default walk speed of the character. So we'll just call the get character movement function once more and repeat the same step. It will just be the max walk speed property, and we'll set this to our walk speed. Okay, so I think that's everything we're doing here. Yep, let's come back to Unreal and hit compile. Now with the compile complete, let's create a blueprint based on our game mode so we can actually spawn as our character. I'm going to put mine in my game mode folder here. I'm just going to give it a basic name. Now normally we would assign the default pawn class here, but before we do that, we're going to create a blueprint based on our C++ character. So we'll come to the C++ classes folder, and we'll find our character class, and we'll create a blueprint based on this. I'm just going to put it in this folder just here. I'm going to give it a name of player character BP. So the reason we're doing this is so we can select the mesh component here and change it to our mannequin mesh. If we assign the mannequin, we can see that it's facing the right way and it's -90 on the location there. Okay, so let's come back to the game mode blueprint. Let's assign the default pawn class to our player character blueprint. Now, one thing we're going to do here is just set up a basic camera just so we can preview the player character. I'm going to position the camera here, drop down the arrow, and hit create camera here. Now on the search filter, just type in search for auto, and we're going to auto activate it for the player when the game starts. We'll just choose player 0 here. So this is just a preview camera. We're going to delete this afterwards, so this isn't final. Let's come to the world settings and change the game mode override to the blueprint game mode that we created. And let's hit play. Okay, so we can see that our character spawned. If If I move forwards and backwards, that works. If I press A and D, I can rotate on the spot, and I can hold left shift to move faster with the sprint. Now clearly our player character isn't animated at the moment. We're going to be tackling that towards the end of this tutorial. Now let's actually move on to setting up the camera system for our project. So this camera over here is just a basic camera actor. Now what we're going to do is create a C++ class based on this camera. And before we do that, let's just make sure that we delete this camera from the map. Let's come to the C++ classes folder, and let's just create a new C++ class, and it's going to be show all classes, and we can type and search for the camera actor, and we can just select that here, and we'll hit next. Now let's name this player camera, and let's put it under the folder of actors, and we'll make it public as well. And let's just hit create class. So as we see here, our player camera is blank in the CPP file, and in the header file, let's just go ahead and set up a public section and create our constructor. So this is just going to be a player camera, and we want to override the begin play function. So this is just going to be virtual void begin play and then override. We're going to add in a U property, which is going to be edit anywhere, blueprint read write, and the category is going to go into camera settings. We're going to declare a boolean, and it's going to be named starting camera. So we're going to be able to select the camera in the level and decide if it's the starting camera when we hit play. Now in the CPP file, let's add the implementation for the constructor. We also want to do the same for begin play, but I'm going to switch over to the header file and just do it this way. So before we add any code into the begin play, we want to make sure we include the header files we need. So the first one we're going to include is kismet/gameplay statics.h. The second one is going to be the camera component. So that's going to be under camera/camera component.h. And that one is important because even though we're working with a camera actor, it does have a camera component within it. So in the begin play, we are going to check first to see if starting camera is true. And now we're going to create a pointer towards our player controller. And this is where we use the U gameplay statics. And this is where we can access the player controller. And this takes in two arguments. The first one is the getWorld function we can use, and then we can just throw in an index of 0. So next we want to check to make sure that our player controller is valid. So if this camera is marked as the starting camera and the player controller is valid, we want to set the view target for the player controller. And the view target is simply going to be this camera, so we can just type in this. The second argument here requires transition parameters. We can just declare the fView target transition params struct. And we can just name this transition params. And we can throw this into the second argument for this function. And that's all we need to do on begin play. Now if we want to set up any default settings for the camera, we can do that in our constructor. To do this, we can call the getCameraComponent function. And within here, we can search for any settings and set what we want. For my camera, I'm going to set the aspect ratio to 2.35, which will give me more of a cinematic look. I'm also going to adjust the field of view, which is just under set field of view. I'm going to give it a default value of 75. Okay, that's all I'm going to do here. Let's switch on back to Unreal and let's just hit compile. Okay, with the compile complete, let's find our camera actor under the actors folder. Let's drag it out into the world. Now if you press Ctrl Shift and P, you can actually pilot the camera. You can see if I go into full screen mode here, if I press G to go into game view, it gives me this cinematic preview of the camera. And we can just hit the arrow here to jump out of it. And because it's the camera actor, we can also come to the details panel here, just clear the filter, and we can search for our starting camera property that we created. We can just check that, and now when we hit play, we can see that it's activated this camera by default for us. So that's the player camera setup. The next thing we're going to tackle is a camera switching volume. So when we enter this volume, we can transition to another camera view. I've still got starting in my filter. I'm just going to clear that. And now in the same folder, we're going to add in a new C++ class, and it's going to be an actor. It's going to be public, and we're just going to name it camera switch volume. And it's going to go inside the same actors folder. So that's okay, we can just hit create class. Okay, so with our new camera switch volume class, let's go ahead and switch over to the header file, and we are going to forward declare some classes. We're going to forward declare the UBox component class, and we're also going to forward declare the UText render component, and we're going to forward declare our player camera as well. Now let's move on to actually declaring our components for the volume. Let's declare a pointer to a UBox component, and we're going to name this box collision. We're also going to create two pointers to a text render component. The first one is going to be named text render new camera, and the second one is going to be named text render previous camera. And these text render components are going to help us place the volume within the level. Let's switch back over to the CPP file, and let's include the header files for the components. So the first one is going to be components/boxcomponent.h, and this one is going to be components/textRenderComponent.h, and we're also going to include our player camera. Okay, we're going to be adding more header files, but for now, let's move on to the constructor. Let's start with the box collision, and let's create the box collision component. So we'll call box collision and create the default subobject, which is going to be the UBox component, and we can just give it a name of box collision. We are going to make the roots component the box collision, and let's set up the default starting shape of the volume. So that will be under set box extent, and this is going to take an F vector. We're going to make it pretty thin on the X axis, so we're going to give it a value of 1.5, and for the other two values we're just going to put in 32. Okay, so let's move on to setting up our text render components. Let's start with the one we named text render new camera, and we'll create the default subobject for this, which will be the UText render component. And we can name this text render new camera. And now we want to attach this to the roots component. So we'll use the setup attachment function on this, and we can just type in roots component. Now we're going to name the text that we visually see in the editor. So we're going to use the set text function, and we're going to name it new camera side. Now we want to make sure that we hide this text when we play the game. So we're going to call set hidden in game and set it to true. Next, we are going to set the relative location for the text. This will be an F vector. We're going to nudge it forwards on the X by 15, and the rest of the values will be 0. And finally, we just want to align the text to the center of the component. So we can use the set horizontal alignment, We'll make sure we use the center enum for that. And then finally, we'll use the set vertical alignment and use the center enum for this one as well. Now I'm just going to select all of this, and I'm going to copy it and paste it in a couple of lines below. Let's select the top text render new camera, and we'll come up to Edit, Find and Replace in Files. We're going to replace the text render new camera with the text render previous camera line. Okay, so we can just come down to Replace, and we can just keep clicking Replace until we get to the bottom line. For the Create Default subobject, we want to rename the text render new camera to text render previous camera. And we want to change the set text to previous camera side. We're going to change the relative location to -15 on the X. And we're also just going to rotate the component. So we're going to use the text render previous camera, set relative rotation. And this will take an F rotator. It's going to be 0 on the pitch, and then 180 on the yaw, and then 0 on the roll. Okay, now let's just go ahead and switch back to Unreal, and we can hit compile. Okay, now let's drag out our volume into the map. We can see the preview text for the volume. This is going to help us just place it easier in the world so we know which side the player character should enter. Now for changing the shape, we don't actually want to scale it because we can see that stretches the text. Instead, we're going to expose some properties on the detail panel so we can change the shape. Let's remove it from the map and head back to Visual Studio. Let's switch over to the header file for the camera switch volume. And we are going to override the equivalent of the blueprint construction script. So this is going to be virtual void on construction, and the parameters for this we can see are a constant f transform reference named transform. Now let's declare some properties. It's going to be a U property again of edit anywhere, blueprint read write, and the category is going to go into volume. We're going to declare a float for our volume width. I'm just going to have a default value of 32. Let's copy our U property line and paste it in again, so we can declare another float for our volume height, which is also going to have a value of 32. Okay, let's go ahead and create the implementation for the onConstruction function. So inside this function, we're going to adjust the box collision's width and height. To do this, we're going to call the box collision and then the set box extent, which takes in an f vector. The x we are going to leave at 1.5, and then we can plug in the volume width and then the volume height as well. Okay, let's just comment this function construction script. And let's head back into Unreal and hit compile. Now compiled, let's drag out the volume. And we can see we've got the volume properties on the details panel now, and we can adjust the width and the height of the volume. Okay, and now all that's left with the volume is setting up the camera switching for when the player exits the volume on either side. So let's delete this and let's switch back to Visual Studio. Let's head back over to our header file and let's declare two new U properties. We can copy the line again and paste it in. We're going to change the category to cameras, and we are going to declare a pointer to our player camera. This is going to be named new camera. Let's paste in another U property and change the category to cameras. And this is going to be another pointer to our player camera, which is going to be named previous camera. So one camera for each side of the volume. Now we're going to declare a function that we can use for the overlap event. We're going to declare a U function, which is going to be void. We're going to name it onEndOverlap. And we're going to add two actor pointers for the parameters for this. The first one is going to be named this actor, and the second one is going to be named other actor. So So this actor is the actor who got overlapped, which will be the volume, and other actor is who entered the volume. Let's create the implementation for the on-end overlap. And now let's head over to the begin play function just further up here. And in this function, we are going to bind the actor end overlap event. To do this, we're going to type on actor end overlap dot add dynamic. And the first argument will be this, and the second argument will be a reference to our end overlap function we just created. So on end overlap. Okay, now we are going to scroll up and include a couple more header files. The first header file we're going to include is under game framework, and it's going to be the character header file. And the second header file we're going to include is the Kismet/gameplay statics header file. Let's scroll on down to the on-end overlap function, and we are going to declare a pointer to a character actor, and we're going to name it player character. And we're going to set this to the get player character function from the gameplay statics. And the first argument will be the get world function, and the second one will be a value of 0 for the player index. Now we're going to create a pointer to a player controller. We'll name it player controller as well. And we can set this to the get player controller function from the gameplay statics. So we'll be using the player controller to set the view target. And if we remember the last time we did this, we declared locally the view target parameters. So let's just do that again. So when the player exits this volume, we're going to switch the camera depending on the relative location of the character. To do this, we first want to check if our player character is valid and if the other actor is equal to the player character. And we also want to check that our player controller is also valid. Now we're going to go ahead and declare a new f vector. And this is going to be the player's relative location equals get transform of the volume. And then we can call the inverse transform position function. And this is going to be the actor location of the player character. So this vector is going to return the player character's position relative to the camera switch volume. So now let's set it up so we can switch the camera if we exit from the new camera side. So to do this, it will be if the new camera is valid and if the player relative location x is greater than 0. And we can comment this if player exits new camera side. Then we will simply get the player controller and then set the view target to the new camera, and we can use our transition parameters. Okay, now we can set up the opposite. So if our previous camera is valid and the player relative location x is less than 0, this will be if the player exits from the previous camera side. Then we can simply set the view target of the player controller to the previous camera, and we can use our transition parameters again for that. Okay, so yeah, I believe that's it. We can come back to Unreal and hit compile. Okay, so now we have everything in place for our new camera system. We can drag out a new camera. Actually, I think I've already got another camera here. Yeah, so I'm going to delete this one. We can take this one. Remember, we can pilot cameras by using Control, Shift, and P. And then we can use this arrow to jump out of it. We've got this starting camera property. We're going to leave this checked, and we're going to duplicate this camera and uncheck this one. And let's place this camera to another position. I'm going to make the character kind of walk towards these stairs here. Now let's jump out of it and let's drag in our camera switch volume. So we're going to make sure our previous camera side is facing towards us. We can use the width and height properties to shape the volume. We've also got the cameras exposed here, so the previous camera side is going to be our starting camera, and our new camera is going to be the other one. So when we exit from this side, we'll switch to this new camera. Okay, let's hit play and try it out. Let's walk towards this volume. When we exit, it switches the camera, but if we also come back through the volume, it switches back to the previous camera. Okay, so this looks good. I'm going to wrap up this tutorial now by creating an animation blueprint for this character. So I'm going to come to my mannequin folder, and I'm going to right click in here and create a new animation blueprint, and we're going to assign this to the mannequin skeleton. I'm going to name this player character underscore anim BP. We're not going to open this up just yet. We're going to come inside the animations folder, and I'm not actually going to use these animations. I've imported Cubold's custom animations because we have access to the turn left and turn right in place animation. So I'm going to create a new blend space here under animation, and it's going to be assigned to the mannequin skeleton, and we could just call this player movement underscore PS. Let's open up the blend space. Let's expand the horizontal axis and the vertical axis. The name of the horizontal is going to be direction. The minimum value is going to be -180. The maximum value is going to be 180. We're going to give it 2 grid divisions, and we can add some interpolation time. Vertical axis is going to be named speed. The minimum axis value is going to stay 0. The maximum is going to be our max run speed, which is 500. And we're going to add some interpolation time there as well. Now let's drag on the animations onto the graph. The idle is going to go on the bottom and the bottom left, and also the bottom right. Next one up will be the walk forward in the middle, and then walk backwards all the way on the left and all the way on the right. And at the top, we can use the run forward, and then the run backward on the top left, and the run backward on the top right. Okay, and we can preview that by holding left shift and scrubbing the mouse across. We can see the direction and the speed is working there. Okay, let's come back to the animation blueprint, and let's open this up. We're going to switch over to the event graph, and we're going to drag out from the try-get-pawn-owner function. We're going to cast the player character blueprint and connect that to the update animation. And we can drag out the blueprint reference pin and get our C++ turn amount property. We can promote this to a variable called turn amount, so we can use it in the state machine. Next, let's drag out the player character reference again and get the velocity. And let's use the vector length function on this, because this will return our speed. We can promote this to a variable and just call it speed. And finally, let's just right click in an empty space and call the calculate direction function. This takes the velocity and base rotation. So let's plug in the velocity function into this, and we can get the actor rotation from the blueprint reference. And we can plug this straight into the base rotation, and we can promote the return value to a variable named direction. Okay, and that's all we're going to do in the event graph. Let's switch over to the anim graph now, and let's create a new state machine. We can just call this base locomotion. We're going to plug this straight into the result as well. Inside the state machine, let's drag out from entry and add our first state. This is going to be our player movement blend space. We can double click on this, and we can right click and type in search for our blend space that we created. And we can just plug in our direction and speed variables into the blend space. Let's come back a step and let's add in one new state. This is going to be the turn in place left, and we can assign the turn in place animation. Make sure this is connected to the result. We can come back a step and also set up the turn in place right. Okay, and now all we have to do is set up the transition rule. Let's do the one going from the blend space to turn in place left. So to do this, we want to make sure our speed is equals to 0, and we can use an and boolean, that our turn amount is less than 0, because that would mean we would be turning left. Let's come back a step, and let's do the transition rule going from turn in place left to the blend space. So to stop turning, we need to make sure our speed is above 0, or we can use the or boolean for this. Our turn amount is greater than or equals to 0. So this says if we are moving, or if we are stood still or turning right, we can transition back to the blend space. Now let's set up the transition rule for turning right. To do this, we will get our speed, and we need to make sure it is equals to 0. And we'll use the and boolean, because we want to make sure that our turn amount is greater than 0, so that will be turning right. Okay, and that will allow us to enter the turning right animation. And to go from right back to the player movement blend space, we will get our speed and make sure that it is either greater than 0, and we'll use the or boolean again, or if our turn amount is less than or equals to 0. So basically, if we're turning left or if we're stood still, we'll go back to the player movement blend space. Okay, that's all we need to do here. We can hit compile, and we can test out the defaults. So if we increase the speed to 500, we start moving. If we change the turn amount here, notice how we don't go into the turn in place animation. We can only do that if we are idle. Okay, so this is looking good for our animation blueprint. Let's close this out, and let's assign this to the player character blueprint. We can just drop down the anim class and assign it here. And now let's jump in the game and test this out. So with the setup, we can see that if we stop and turn, we can turn left and right with our turn in place animations, and our blend space is working with the run and the walks. So I'm going to finish this tutorial by setting up some more camera transition volumes, just so we can see how this will work. So I'm going to duplicate this volume over to these stairs up here, and you want to make sure you probably name your cameras and volumes. I'm going to skip that for now, but the previous camera is going to be the last camera before we hit this volume, and then we're going to duplicate this camera, and we can hit Control Shift and P to pilot it. I'm just going to place this up high here, so when we go through this volume, we're going to transition to this camera. So that will be the new camera. Let's use the medicine dropper tool and select it. Let's duplicate the volume once more, and let's place it on this entrance just here. And let's select the previous camera, or the camera that will be active before we enter the volume. And let's duplicate this camera, and let's place this one. I'm going to place it just further back here, just so we can get the statue in view. And we can also adjust the field of view for the camera just on the side here. Now let's come back over to the volume. Let's select it and assign the new camera. And I'm just going to finish by duplicating this volume once more. And we can assign the previous camera again to this one. We're going to duplicate this camera and pilot it with Control Shift and P. And let's set it up in this room over here. Okay, so we'll just select the volume and then assign this last camera to the new camera slot. Okay, now let's hit play. We can go into full screen mode with F11. And we should be able to transition through all of these different camera angles now. So that's it for this tutorial. I hope it's helped. And if you want to support these types of tutorials, make sure you subscribe to my YouTube channel. And I've recently set up a Patreon page, and you can see the link for that on the screen at the moment. So stay tuned, I'll have more C++ tutorials coming soon.